All right. What is the normal distribution? That's the first question we want to answer today. So, the main idea is that you have the average bell curve. All right. So, the word average comes to mind, which is your mean, and it's also a bell curve. Now, we know if you're ringing a bell, it looks something like that. All right, that's your bell. All right, so that's what the curve looks like. That's what the normal curve looks like. It's your average bell curve. Imagine you're measuring the height of 1,000 adults, and you notice something interesting. Okay, most people are around the average height of, say, 1.65 meters. Okay, so you've got 1,000 adults, right? So the total number of adults that you measuring is 1,000. Measuring one by one, take a long time, and eventually get to 1.65 meters. And there are fewer short people who are a bit shorter or a bit taller. Okay. So in other words, if you look at the bell-shaped curve, or what we're saying here is that majority of the people are close to 1.65, and there are few people who are further away from it. The further and further you get away from it. So there's few people who are extremely short as well, and some people, very few people who are extremely tall as well. And so when you plot this on a graph, so if I have to plot this on a graph, and we have got the really short people on one end, and I've got the really tall people on the other end, you'll find that there's very few short people, very few increasing slowly, and then a lot of people in the average region, and then it decreases as you get taller and taller and taller. All right, where we would say that the central space between short and tall would be the average. So you'd have two people here, let's say, this was two, and that's four. And then you can see that you could say the area underneath it almost gives you that the amount of people. If you have to put the y-axis on this, let's say this was a y-axis over here, which actually gives you a number on one side. So let's say this is the total number of people. And we could say that's two increasing to 500, and then going back down that way. All right, and then on the side here, we would say the average height was 1.65, in which case it can reach all the way down to, let's say, 1.2, and all the way up to maybe 2.1 meters, the rare case of someone who's really tall. Okay, so if we plot it in the graph, it forms the same bell-shaped curve, hence the nickname the bell-shaped curve. In this distribution, the bell-shaped curve is known as the normal distribution. And the normal distribution exists in the world in many different examples. You could even look at class marks. Let's say your average class mark is 60%, and you'll notice an average means that most of the people will be there, and some people will do really bad. Maybe they didn't study, or maybe there's students who are in a class that are really weak. We get to 20%, let's say, or 30%, or maybe being too harsh, maybe 40%. Either way, depending on the class and the level of the class, there will be some who get really low marks, but the majority will fall into the space here close to the average. And then some of us will get really good marks. We get someone getting 100%, maybe 90%, etc. If it was marks over here, right, and the total number of students on the y-axis. And you could do this for any example in the real world, and you'll notice that the extremities in any kind of statistical analysis or collection of data, there are fewer extremities than there are those closer to the mean. All right, so the next thing is looking at the features of the normal distribution and what it's all about. But for now, to answer the question, what is a normal distribution? That is it.